which we haven't talked about yet in Java, but you have seen it to a certain extent, I am sure, in C++. The idea is static. Okay? It is by and large the same purpose for which we use it in C++, with a little variation because you are dealing with Java. Okay? So, I don't know how many of you recollect, in C++ you have heard the word static, correct? So what is, when I use the word static, what immediately comes to your mind? Very good. So static is something which belongs to the class, doesn't belong to the instance. So I am sure you know by now that some things belong to the class, some things belong to the instance. Methods belong to the class. Methods don't belong to the instance, correct? Because methods though are invoked on an instance, if you have two instances, two objects, the methods are not going to change. The data may change. The number of the employee, the name of the employee, the salary of the employee will change. But the way he gets transferred, the way he gets a promotion, the way he eats, the way he talks is not going to depend on what object we are referring to. That is going to remain the same. So objects don't have their own methods. They get it from the class. Similarly, there are certain kind of methods and variables which can be only invoked in a static context. So now one of the, okay, before we go to static methods, let's talk, we will talk about static methods for sure. You see, right now on the screen itself, there is a very good justification for static. Why is main static? Very simple answer. When main is invoked, is there an object in existence? No. So the class that you are creating, for example in this case, the class that you are creating is test. And when JVM gets called, it is given this test.class or test. Whatever file, the bytecode file, right? So when it is given that test file or test program, the test object is not instantiated, only the class is existing. Whatever instantiation has to happen in main. So to create main, there is no one, there is no instance. So that's why, because nobody can create an instance of test when this program starts, there is no question of main not being anything other than static. It's a method which has to be invoked at the class level only, because only the class is existing. An instance of test is not existing. If I want, I will create an instance of test. So a method which does not need the existence of an instance is another way of saying the method is static. So basically, I do need static methods. Generally, to start a program, the main has to be static. Elsewhere also, there are a lot of static methods we will see. So now what we are going to see is what do you mean by introducing this concept of static in a standard class. As somebody said, it belongs to the class, does not belong to the instance. So let's quickly do this and understand that it belongs to the class. So we'll say class, give any name, class M. So we'll define a variable. We'll define actually two variables. One will make it static. So int x, no, okay, one regular variable, int x, and we'll make another variable static. For common example, I'll call it count. So static int count. So I have two variables and I will write a constructor. The constructor will initialize, will take one parameter, int a, and it will initialize x equal to a. It will initialize that instance. And count, I will just say count equal to count plus 1 to count the number of instances. Okay. And okay, so let's keep it this way. So just to summarize what we are doing, we are creating a class, a regular class called M. For a change, we have two variables, one regular variable and one a shared variable. When you declare a variable as static, it obviously is shared amongst all the instances belonging to that class. It's shared among all objects of that class. So that is what I say by making line 3 static int count. Then I say I have a constructor where I use some variable to set the value of a and count increases. Now we just go and demonstrate how how M works, or how the static part of M works. Okay. So we have new M and with a constructor 10. Okay. And again we create, let's call that M1 just to keep counting easy. M1 is equal to new M10. We create one object. Now we create yet another object. M2 is equal to new M15. And now what we do is that we say system.out.println. Okay. M1 dot x and M2 dot x. Print one more. Okay. M2 dot x. You will get two different values, and then we can print, as you know, the use of static. Yeah. We'll say M1 dot count and M2 dot count. So what will I get? What output will I see? Count need not be initialized. Static variables automatically, it's instance variable. So static variable also gets initialized. Okay. What will I see? Yeah. So at the top you will see 10, 15, because each M1 or each object has their own copy of X, and one copy of X does not interfere with the other copy of X. Then we have M1 count and M2 count, and now you will see that we will get 2 and 2, because that count is a shared variable. So first time when M1 got created, count became 1. When M2 got created, count became 2. So because it's the same count, because it is marked as static, the count variable is shared among all instances. So to just depict it pictorially, okay. Yeah, just to show it pictorially, you know what happened. So I have the heap. So I have two M's. One is M1, another is M2. Each one of them has their own private copy of X, but together they share one copy of count, which is also on the heap. Actually, you know, static variables are not created on the heap. They are created by, this is a very JVM specific thing. They may be created on the heap, or sometimes they may be created on a special memory. Anyway, right now it doesn't matter. What matters is that it is shared among all instances. Okay, and that is what M1 does. When we create this shared variable, it gets shared between these two, and automatically. And so whenever M1 got created, count became 1, because it's the same count which is getting updated. When M2 got called, count became 2. This is a very common use of static. You would have seen that probably when somebody showed you in C++ also. It's the same thing, that the same variable is shared between all instances. So we'll just confirm it, display it, play with it and see it, that we are seeing X and X are different. One is 10, one is 15 as expected. But count is shared. So one guy increased the count, second guy increased the count. So I see the updated value of count, isn't it? So I see count as 2 and 2, not 1 and 2. Because when I am printing count, both the M1s have been created, both M's have been created. So I get count as 2. Now this is the easy part, that I have a static variable and I can use that. Okay. Now besides static variables, Java also permits like C++, and there you have to be a little careful. By the way, as somebody pointed out, static variables are by default initialized to 0. So you don't have to worry about it. Like all instance variables, they are also initialized to 0. So you don't have to it's not wrong to initialize, but you don't need to unless you want to change some other value as the initial value. If you want 0 and you are happy with 0, it's fine. So now we have discussed just basic static. Now what we are going to do to M1 is, I'm going to make static private. I want to introduce this private public separately, but this is a good occasion. So I want to make static as private. Okay. So now what will happen? Line 14 should give you an error, because now test is a separate class, M is a separate class. I cannot access private variables of M in test, correct? So let's see whether we get that error or not. Okay, we have to say, now you can see m1.count is giving us an error saying count has private access in M, and basically the same error again. Okay, m1.count, m2.count, so that's why you are getting the error twice. Fair enough. Now you know why you are getting the error, okay? So because I marked that static variable as private, it cannot be accessed in any other class. It is only available in that class. So what I decided to do is, I decided to create a method to give access to that variable. Let's say getCount, which has an int. This is how you normally give access to private variables, isn't it? If you don't want the world to know what variables you are using, what will you do? You will create those variables, keep them, mark them as private, and write what are called getter methods or setter methods. Getter methods to retrieve data, setter methods to set the data, because the outside world doesn't know how I am storing the data. That is called encapsulation, right? Somewhere in object orientation probably you have figured that out, that what happens inside a class, how it happens, is none of the outside world's business. Outside world would only like to invoke the methods and things will happen inside the class. What we mean by that is the object or a class is a black box. What happens inside, how do I care? As long as it does what it is supposed to do. So now I wrote a method called getCount, and I altered the thing to say getCount. Okay, now there are a few things which we will try and understand. I'm just going little forward. Okay, so let's run it. Okay, now as expected, it gives me count. Yes. Now please follow this line by line. There is meaning in every other line, every line. Now we go back to the code and observe something. Now what do I have? I have a private static variable called count, which is getting incremented every time an object of class M is created. Fair enough. And then I have a getCount method. Can you see? Now if I ask you, what kind of method is getCount? You will say, is it a static method, or is it a class method or an instance method? getCount. It's an instance method, because why? Because it's not marked static, right? Methods which are not marked static belong to the instance. They don't belong to the class. So now we have an important rule in front of us. What is that rule? Instance methods can access static variables. No, yes. I have an instance method. getCount is an instance method, not a class method, right? So I don't have a class method in that class. There is only a class variable called count. So there is no class method. Still, I am able to access count. So this is a very important thing which comes in a lot of these quizzes which you have in Java. People try to trick you with this kind of thing and say, will this work? Will this compile? Yes, it will compile, because Java has a very simple rule. Static variables can be accessed from instance methods, but the vice versa is not true. You will understand what I mean by that in a moment. Okay, in two moments. First moment will do now, and the next moment. So what will work? Instance methods can access static variables. We are seeing that working. We just saw that. No problem about that. correct? Now let's try to use a static method for a static variable. So what we'll do? We'll mark get count as static. Will it work? Will this work? No, yes. So now get count has changed its status from being an instance method to a class method. But what kind of variable is that static method accessing? A class variable only. It's a class method and it is accessing a class variable. We should not have any quarrel with that. And we are accessing using m.m1.getCount. That is, we are using it using the instance. We can do it differently also, but we'll keep it like that for a moment. Now a static method can also access static variable. So now please remember the way we are going. Instance method can access static variable. We just saw that earlier. Static method can also access static variable. No problem. We saw that. Correct? Now we will run it and show you it is working. And there is one more way of style of making it work. Okay. So this is working. We are getting the same consistent answer. Now go back. Now because the method has become static, I can access it in one more way. Can you comment out 17 for a moment? We are commenting out 17 and in its place we will say system.out.println. Okay, now because getCount is a class level method, is there any other way I can access it? I can access it using the class name. That is, I can say, instead of saying M1 and M2 or using the instances, because now it's a class level method, m.getCount. This is valid. Why is this valid? You can't do it with any method. Unless the method is marked as static and that method can only access static variables, it can do. Okay? Yes, no? So I am able to access it at the class level. See that, m.getCount. That's because the method is a class level method. It does not depend on the existence of an instance. If I don't create any instances and still say m.getCount, it will give 0 as an answer, correct? We can check that in a moment. First let's run this and see whether it works and then proceed. Okay, so this as expected, because I am printing it only once, I got a 2. Now let's go back and if I say I don't create 2 instances, that is I comment out for a moment 14 and 15 both, so no instances. Obviously line 16 will also have to go because that depends on, line 16 is out. So see the thing I am doing. The only valid line in my code, main code is m.getCount. Will it work? I'm just asking, will it work? Why not? I am not having any instance. So getCount will retrieve the value of count. Because I have not created any instance, count would not have changed. Count will continue to remain at 0. So I should get 0, correct? So let's see whether I get that. Okay, I got a 0. Yes. Because I just said m.getCount and I get a 0. Because no instance has been created, the constructor never got called, and therefore I got a 0 twice. Not 0 twice, I printed it only once, so I got a 0 once. No surprises there. So let's uncomment that part, the instances part. So now I have 2 instances. Okay, now I am going to reiterate the rule that we learned. A instance method can access a static variable. A static method can also access a static variable. So where does the difference come? Okay. Now, and an static method, which is class method, can also be invoked at the class level only. It doesn't need an instance. Now comes a small issue. Now I am going to the method getCount, and in that method I am going to say, let's say return x for some reason. I am going to say return x. Now, will this work? Yes, no? No. This won't work. This won't work. Why it won't work? Because X belongs to an instance and the get count belongs to a class. Now, a static method can only access static variables. I am repeating again. A static method can only access static variables. It sounds to logic, right? It's logical. When instance is not existing, still static methods will work. And you know, unless an instance is existing, will X exist? No. Will Y exist? No. Static variables can exist. So static variables, there is no problem. But X and Y, or in this case just X, they depend on the existence of an instance because they are instance variables. They don't have their own independent existence. They exist only if the instance exists. Remember, I showed you in the picture, only when you create an object of type M, M1 whatever, then X comes into existence. X does not come into existence by itself unless you have an instance, and that instance has an X. Whereas a variable like count doesn't need any object to come into existence. It has an existence by itself. The moment the class is loaded in memory, that instance is there, that variable is there. So when we came to get count, and get count was accessing only count, we had no problem because it was accessing only a static variable. The issue started when we made get count try to access X, which was an instance variable. It didn't work. It won't work. So now let me state the rules again. And please remember the rules. Static methods can access static variables compulsory only. Instance methods can access static variables also, instance variables also. Static methods cannot access instance variable. The simple way of thinking about it is, when you mark a method as static, you are calling it a class level method. A class level method can only access class level variables. End of the matter. So if you try to access X, it is going to shout. It's not going to work. Whereas an instance method has access to everything, whether it is static, not static, instance, whatever, it doesn't matter. Instance level method can access, because when an instance is created, class is anywhere there. So class variables are always available. Correct? And where is the question of not having access to class variable? But class variables cannot be accessed, instance variables cannot be accessed through class level methods, because class level methods do not presuppose the existence of instances. So obviously what they have done, they have said class level methods can only access class level variables. They cannot go to instance variables. Instances can access both instance variables and instance methods and static variables. Now we have seen one use of static. No, actually two. We have seen what a static method can do, and we have seen what a static variable can do. We have seen these two. Now, does the purview of static end here? Well, this is what is important, but there are some more things which you have to remember about static, which normally Java programmers don't understand, don't do, are not, they are ignorant about it, but you should know. So I am going to just demonstrate one more thing where static is important, actually two more places. So we will talk about these two more places of static, okay? Because you need to understand language at depth. So let's talk about two more cases where static comes useful or is necessary. So I will take another example. Can we open another? Okay, we are opening another called Java Lab 2. Okay, I suggest you also do the same. Whenever there is marked change in code, we take a different example. Okay, I'll do static overriding. Please understand, there is this. Now I am going to talk about overriding and bring static. Okay, so I'll say class A, class base, okay, has a static method, static void M1, and we'll say M1 of base called. Okay. Then we'll have another method M1, which is an overloaded version, but it's an instance method. M2, non-static. In this class base, I have two methods. One is static, one is instance. Agreed? Agreed, not agreed? Yeah. Then I have a class derived, extends base. I'm going to override both the methods. Just to show you, I'm going to make the M1 as non-static in the derived class. Okay. And I'll say M1 of derived call. Derived. Okay. Now, before I even proceed, do you think this will compile? Forget my main. I'll write some main and put something there. But do you think this, do you see any anomaly here? You see an anomaly or no? Don't see an anomaly. Yes, no? Does anyone see an anomaly? Something fishy, something wrong. Okay. Huh?
M1 is method of base. It should only belong to base. But we are trying to override it in derived.
Sorry?
M1 is a method of base class. So it should belong only to base class. But we are trying to derive again.
So, here is a rule. Static methods can be overridden with static methods. So this won't compile. Why? Because M1 is static in the base class and M1 is instance in the derived class. This is not allowed. Okay, let's just compile this. We'll not even write, we have not written the main code. We'll just see whether it compiles. Okay. So if you see this, you will get an error. M1 in derived cannot override M1 in base. Why? Because one is marked, their signatures are same, but a non-static method cannot override a static method and vice versa. Vice versa means, if I had M1 as instance in the base class and had I marked it as static in the derived class, then it won't work. Important thing to remember. Can you remember? No, yes. Very, very crucial to remember because this is a common error you do when you make classes. Okay? Static, static. Instance, instance. It cannot be mixed. You cannot mark it as static in the base class and have instance in the derived class. It should be same if you are overriding it. Okay? Achha. Now, so I will make it static. Now observe one more. I am marking it static. Now things will compile. Everybody happy? Static, static, instance, instance. Now let's go to class test. Okay. Please keep trying this. I am going to class test. Okay. Now I am going to create, okay, main. Okay, now I will create a base reference B. Base reference B is equal to new derived. Anything wrong with line 19? I have overridden static with static, instance with instance. That error I have removed. Anything wrong? Anything wrong with line 19? Okay. No? No. Agree. Nothing wrong with line 19. Now look at line 20. What is M1? Method in base class, which is overridden in derived class. Yes, no. Now, I told you in Java, polymorphism is automatic. Did I say or not? No, yes. So, with that rule, when I say b.m1, which m1 should get called? Because at runtime b is pointing to whom? Derived object, no? No, yes. You are seeing no. B is pointing to a derived object. I always said in Java, it is what it points to decides which method it is getting called. That's how polymorphism works in Java. You don't need that virtual zero, all that kind of fanfare or fuss that you do in Java programs. In C++ programs, we don't need that in Java. So here it's automatic. Okay. But let's just see what happens when M1 is static in both. Right. Okay. Let's just do this. Yeah. Now you see a variation. Can you see the variation? No, yes. Did you understand anything? So, polymorphism doesn't work on static methods or class methods. Very important rule. In Java, polymorphism works automatically as far as, we didn't talk about it when we did earlier, as far as instance methods are concerned, no issue. But when it comes to class level methods, can you see the variation, difference? You see, can you go to the answer? Execution. Okay, watch this. Which M1 got called? M1 of base got called. You can see it on your screens also. M1 of base got called and M1 of derived got called. M2 of derived got called. M2, no problem. It's an instance method. So overriding happened properly and overriding was done. No problem. That is how it is. But if you look at M1, which is a static method, first we learn two rules. Static can be overridden with static, first rule. Second, when you do overriding of static, polymorphism doesn't work. The decision on static methods is not done at runtime, it is done at compile time only. At compile time, what is B? At compile time, B is base class. It is only at runtime that it points to a derived class, derived object. Runtime doesn't matter for static. What B is at compile time, decision is done then. Decision is not delayed till runtime where B points to derived class. So late binding does not work on static methods. Late binding works only on instance methods. What is static? When do you use static? What is the implication of static? When do you do static overriding? When you don't do? This comes in big projects. Small projects won't have this, correct? But you should know all this because I am hoping one day you will design big stuff. Okay. So class base M1, we have static, M2. The moment I knock off static from both parts, M1 and from there and there, you will see automatically polymorphism will kick in. We'll just confirm that. So we'll knock off static and static because we have to knock it off both places. Otherwise it won't compile also. Now you will see polymorphism is back in full swing. Okay. You see M1 of derived called, M2 of derived called. Over. Now you see polymorphism in action. The moment I removed the static keyword. Both places. You have to remove in both places. Understood? So, let's just recap what we know about static. Static belongs to the class. Static methods can access only static variables. Instance methods can access static as well as instance. Acha, here I want to point out, some of you will go to learn .NET, C# and all. Here there is a small variation between languages. In in Java and C++, we allow instance methods to access static variables also. Okay. In the modern languages like C#, they have stopped that. They say only static method can access static variable. If through an instance method you try to access a static variable, Java allows, C++ allows. C# says no, I will not allow. This is illegal access, I will give an error. Java says I will permit, though this use is strange because it carried a lot of things from C++, it said okay. But in C# it says no, I will not allow. If you want to access a static variable, you access through a static method. I will not allow access through an instance method. That is refinement. As people evolve, they find this mistake often. It's a mistake, it's a feature, whatever you want to call it. But in evolution of language, they stop that feature because it's not a good thing to encourage. They said very simply, if your variable is static, create a static method, access it through that, no problem. Don't access it through an instance method, which Java allows. Okay. Okay. Now we'll move on to another thing which I had not mentioned when I talked about object creation, because I had not done static till then. Okay. Now, just to illustrate, okay, this is important when we discuss mixed language programming. Now you'll ask, what the hell is mixed language programming? You know, there is a lot of code which is written, the same code, it's one code, not different codes, which is written in different languages. That is, part of it is written in one language, part of it is written in another language. This is a very common occurrence, okay? And when that happens, you know, there is always this issue, why would you first do it this way? In Java the case is very strong because, and in Python also the case is strong. Why do we do mixed language programming? Because we feel, for example, in many problems, 80% of the standard code is written in Java. But what they would do, 20% of the code which has to run really fast, they say, no, I can't use Java for it. It has to run very fast. I'll use C or C++ for that. Okay? I can't use Java. Java will be too much. So what do we do now? You have two languages existing in the same code. Often, for that to happen, and that is one of the occasions where it happens, when a Java class is using a C code, they have what is called as a wrapper, which is called JNI wrapper. JNI stands for Java Native Interface. This idea of native, those of you who are attending Unreal will also understand that in Unreal also there is something where two languages are coexisting. If you have attended Unreal, you will understand there is C++ existing and there is Blueprint existing. And always there is this jugalbandi between the C++ part and the Blueprint part. Because for certain things, the programmer might decide to use Blueprint. For certain other things where logic is very strong, he may decide to use C++. So this is always a problem, or always, call it a problem or call it a feature, that two languages coexist. Okay. Now, in Java, they introduced this concept called static load. I'll just mention this and then perhaps some of you will understand. Okay, what we have is a C or a C++ library. Sorry. Somewhere you have this library. Okay. It is immaterial where this library will be. I'll tell you one area. Those of you who are doing GPU programming, you know, people program GPU in C, C++, C or C++. But they want to use this GPU code, matrix multiplication, whatever, either in Python, so that's why they have something called PyCUDA, okay, or they have Java as their main language. So then they have part of the code, the high performance code written in C++, which runs on the GPU, and they have the low processor code, low processor means low capacity code, which is more to do with GUI and lot of other things, that is written in Java. Okay? So imagine for some reason that you have a library, and let's pretend that you have some MMUL, matrix multiplication function, implemented in C, C++. Let's just pretend this. And let's say the library is called GPU lib. Okay. And here you have your Java program. Right. In your Java program you have a main. Okay, I am not writing the whole main. In the main, what you want to do? You want to say GPU G is equal to new GPU, and on this G you want to call MMUL, a method. Now I hope you are understanding what I am trying to say. I have a C++ library written for GPU programming which knows how to get the work done in GPU. That library is called GPU lib, okay, and it has a function, nice good function called matrix multiply, right? Now I want to write my code in Java, but I want to use the matrix multiplication code from GPU library. Why? Because that's fast, simple reason, right? Very common requirement. No, please believe it. Very, very common, very, very useful, and you should know how to deal with it. Okay, then the question that comes is, how do you set this all up? So, when your program starts, before your program starts, this GPU lib has to be loaded. If it doesn't get loaded, how will you create this class? How will you do that? So normally what they do is, they have in this class a static loader, or they call it static initializer. The beauty of the static initializer is, it gets invoked even before the main gets invoked. That is the only thing which gets invoked before the main gets invoked. Why? Because static initializers first come when the class is loaded, that is this test class is loaded, that time only static initializers are loaded or static initializers are executed. In this static initializer, we'll write a small one today, right now, we will load a library. Because by the time main starts, I need the GPU available. The GPU is a class coming from C++, this library. Between this, we also need a JNI wrapper. I am not talking about it. This library cannot come as a naked C++ library. It has to be wrapped in a JNI wrapper. Okay? How to do that? We'll talk some other time, or you can refer. It's a big process. It takes about an hour to explain how to create a JNI wrapper for a C++ class. That is a Java wrapper, Java native wrapper for a C++ class. But in many ways, it is very similar to what C++ does with Blueprint and Blueprint does with C++. It's very similar. It's some kind of encapsulation, hide the details, bring it at a abstract level and invoke. So this library has to be wrapped in a JNI wrapper and brought. And then in the static initializer, it has to be loaded. It will execute before the main runs, and then your function will work. So, understanding this requirement, understanding that today or even 20 years ago, there was a lot of mixed language programming happening. Now here I gave an example of C++, but the same thing can happen with Fortran, same thing can happen with COBOL, same thing can happen with Python. Part of the code is written in one language, you have a wrapper for it, it has to be loaded before your main starts, and then your program starts. So the basic thing, forget everything else. If you understand just what I'm just going to say, it's adequate. Some programs need something to happen even before main starts. Can you appreciate that? Normally what we are told, main is first thing that happens. Well, that's true, but before main can come, this C++ library has to be loaded. Something else may have to be done. So if that something else has to be done, where will you do it? For that construct, they have provided what are called static initializers. So that is the reason why the Java creators decided that we should have something called static initializers, which will get called before main does. Just to test, okay, I'll ask the question the way it is asked. So we will clean up this code. This is done now. We have explained this use of static. We have come to a third use of static. Okay. Yeah, if you have another lab open, fantastic. This is day 10, lab 3. Okay. Now I'll write the code. So class test, and it has a main. Okay, we'll just write the main first. I'll tell you how this question is asked. It's a very common question asked in Java interviews. Public static void main. Okay, we'll say welcome to KMIT. SOP. Achha, the way the interviewer checks whether you initializer or not is like this. They ask this question, without changing main, can you print something before main? Before main means before welcome to KMIT. I want, let's say, a message, welcome to Telangana. After that I want welcome to KMIT. I cannot change main. Yes, no? Are you understanding my question? I am saying you are not allowed to change main, even one line. Lot of people who have this hang up about main. Main is the first method after the program starts. There is some occasion where the program has not yet started, still there is a provision. What is the smart answer? Smart answer is use static initializer. Now you will say, what is a static initializer? Use it, that is the initializer which gets called after this class is loaded by the JVM, even before it starts looking at main. Main is the first executable method, but static initializer is coming at the loading time only of the class, this class. So first the class has to load, then main has to run. Something you are doing while the class is getting loaded itself, if you want, you can add a static initializer. So the answer is static, just say printf, println, okay, welcome to Telangana. Okay, now you will see what is the effect. Okay, as I mentioned, can you see the difference? So even before main got executed, the static initializer automatically got called. It's a loading time of the class. Followed? Yes, no? Okay. Now, there is a close cousin of static initializer called instance initializer, which had a similar use but at an instance level called instance initializer. Okay, I'll just introduce it. Okay, not important to be very clear about it, but you should know. Now we will create a class before this, class something. Okay, class A. Okay, and I'll add two initializers to A, static initializer and instance initializer. Just observe static A. You say system.out.println. Just observe this. Okay, it's all very important parts. Static initializer of A called. Okay, then we'll write a constructor for A. We'll say constructor for A called. Okay. Then we'll have an instance initializer for A. Open bracket, close bracket. Instance initializer of A called. Okay. Let me now elaborate. Can you see class A clearly? It has got three things. It has got a static initializer? Yes. It has got a constructor. Yes. And it has got an instance initializer. When does, now I am going to just say, you tell me what is the output. I am just going to give the rule. Okay. Before a class is loaded, static initializers are called. When an object is created of a given class, first an instance initializer is called, then the constructor is called. I will repeat the rule again. When a class is loaded, static initializer is called. Loaded means loaded by the JVM from the hard disk into main memory for execution. When a class is loaded, static initializer is called. When an object of a class is instantiated, first the instance initializer is called, then the constructor is called. So even before you enter the constructor, if you have an instance initializer, for that instance something before constructor. Okay. Now, okay. So now you are looking at the whole thing. Look at from class test. I'll go and change class test. Okay. I'll say after welcome to KMIT main law, I will create a small a is equal to new a, create an instance of a, and that's it. Okay. So now you need to tell me, okay, who comes first? Which line comes first? Which one? Welcome to Telangana will come first. Fair enough. Which line comes next? Welcome to KMIT comes next. Agreed? Because class test has to load. That's the executive in class. When the class test loads, then only everything else is needed. So class test is the public class which has the main. So first welcome to Telangana, then welcome to KMIT, then A is instantiated. It's only when you instantiate A, the need for the loading of that class comes. Correct? Otherwise, you can't load class just like that, no? Because you are instantiating A is to be loaded. First it has to be loaded, then it has to be instantiated in memory. So, what will happen now? Then static initializer of A called, you agree? Then instance initializer of A called, correct? Then constructor of A called. You agree with me? Okay, let's observe what we see. Yeah. Now, as expected, first came welcome to Telangana, because main has to come. Main class got loaded. Then welcome to KMIT. Then I looked at A, or JVM looked at A. First it had to load A. Before you load a class, how can you even call a constructor or anything on that class? So that time static initializer of A got called. Then before any constructor gets called, instance initializer gets called. Instance initializer, how do you write? Just open bracket, close bracket, anywhere. No name. Static initializer, how do you write? Same way, only thing is you precede it with the word static. Okay? So if you write just open bracket, close bracket, not belonging to any method, it becomes an instance initializer. And add, just I'll do this and I'll move on. I can add, there can be more than one static initializers, there can be more than one instance initializers. In which order they are called? The order of appearance in the class. Okay. So now I will just add after the constructor A, I'll add another static initializer called instance initializer. Okay, we'll just add another instance. First all static, top to bottom, then all instance. So we'll just copy that. Okay, we'll just say second instant initializer of A call. It's in the order, chronological order or whatever order you want to call it, from top to bottom. Okay. So we'll see the effect. Run it and see. Huh? No, static. Same order will be for static also. All static will be called first, then all instance top to bottom. Okay. You can add another static if you want. Okay. Okay. Second static, first static. Okay. Now, in one example, you should know everything. Okay. Watch. Okay. Welcome to Telangana. Welcome to KMIT. First static initializer of A called, second static initializer of A called, first instance initializer of A called, second instance initializer of A called, then constructor could call. So, lot of people who misunderstand Java, they think constructor is the first method to get called, finished. Java has lot of power. Only thing is, you need a smart guy to get access to that power. You need to be smart. You need to be clever, you need to understand, then you can make anything happen. Okay? Especially now, Java has that kind of features. But Java has, again, it's like this. It's in a, you give a, I always use this word. If there is a highway, you need a fast car. That's why I want people to be multilingual. You choose what you want. Let the customer say, which language do you want? I'll write in that language. I have no problem. Okay, now we have talked about static, we have talked about initializers, all kinds. I think I had one more thing to talk about. Yes. Maybe now. Okay, so let's stop conceptual thing. We have 3-4 programs today. So it will give you a little time to do them also. Please don't cheat. So we'll open one by one. They are good programs. Try and do them so that your programming style also, programming side also develops. Yeah, read the question, try and understand. And then try and solve. Don't copy and solve. You need a pos variable to keep track of where you are in the outside, in the bigger string. And initially pos will be 0. So next time when you search, you will have to start from pos onwards. And when you find it, you have to do a break of the inner loop. Smart loops, that's it. About 5-10 lines code. Okay, we will start looking at the solution at 11:15. 11:15 should be okay. One loop which goes through the smaller string, which you have to check is a subsequence of not. And the inner goes through the bigger string. Go character by character from the outer string. Look where the character matches. And once it matches, break out of the inner loop because you are done with that. But next time you start the inner loop, you start from this position plus 1 because you want to go from the next position in the bigger string, because you have to search only next for that character. You can convert both the strings into character arrays if you want, or you can use char@. Either way is fine. I think we'll start solve. Okay. So in input we'll be getting 2 strings and we'll be returning a true or a false, right? So let's start writing the code. I'm just writing for one of the questions at least, the code fully from beginning. So those of you who are completely lost can still follow. So class test, now I have the main. Okay. Now we'll create the java.util.star. And we'll create the scanner. So we got the scanner. Now we have to read two strings because our input for the program is two strings. So let's call this string S1 and sc.next, and string S2, the second string. Okay. We can figure out now what we are going to do. We are going to go through the first string is the bigger string, is it? Go to the code. Question. No, first string is a smaller string whose presence in the, whether it's a subsequence or the second string. Subsequence means not substring. The sequence of the characters should be same, that's all. And it should occur in the second string. So, okay. Now, we'll say for each char C, is it, no, this won't work. Char, if you convert it into char array, it will work. For each char C, S1 to char array, Okay. For each char C in that character array. What is that character array? Converted version of S1. What we are going to do is, we are going to start from position. So let's mark the position as 0 initially. After that, make pos equal to 0. Okay. And we'll start from position and search from position for I equal to pos or something, int I equal to pos, because we are going to search from that position, int I equal to pos. I less than the length of that string, S2 dot length, length, length. Length is a function, is a method on S2 string I plus plus. So I'm going to start from length and go, start from pos, go up to length I plus plus. Okay. And what am I going to do? I'm going to check whether that particular character matches that character in S2. If C is equal to S2 dot char at I. Okay, I am comparing the character from char at I. Okay, if it is equal, then what does it mean? That corresponding character here has matched with the character in S2 starting from pos. So at this stage, what do you think I should do? If it is matching, what's the point in staying in the inner for loop? Because that is to compare. So I say break, and where do I keep incrementing pos? Elsewise, in the inner for loop, after the inner for loop, no, not inner for loop. See, as I am comparing, as I am going, so at that when the character is there, I have to update pos to I, you see? Okay, before breaking, pos equal to I. Because I have to remember that point, and next time I have to start from that point onwards. So should I say pos equal to I, or should I say pos equal to I plus 1? I plus 1? Because I have to start from that position next time. Right? Okay, and break. Now, what if I reach the end of that string and don't find C? Because that is when I have a problem, correct? That means I have taken a character C, gone through the entire second string and not found character at all. But I have, so I may come out of that for loop because of a match and a break, or I may come out without a match. How do I do that? I use a flag. So I say int flag, line 7. I mean, there are many ways of doing it. I am trying to make it as simple as it can. Flag equal to 0. Okay. So I make flag 0 before I start the search. You can make it there or after line 9. Before you enter the inner for loop, you should always start with a flag equal to 0. 0, 0. And when you find it, you will make flag equal to 1. Now before breaking, flag equal to 1. So you found it, so you came out. So if flag equal to 1, after you come out of the for loop, you will continue. But if flag happens to be 0, that means you didn't find any character matching to that character in the entire length. Then what do? You're done. You can't proceed with this, because one particular character is not occurring at all. So if flag equal to 0 remains at 0, you didn't find a character, then what do you have to return? Then you have to say SOP false, and you have to exit, no? Because it's a program, you can exit. System.exit. System.exit 0. And then there's no point now going forward. Okay. Now, if your for loop finishes, that is the outer for loop finishes, which is here, okay, then you say what? You say system.out.println true, because you have finished the for loop, you did not find a single exception. We'll write that and we'll correct it if needed. Okay, now let's walk through the code. So I've read the first string, I've read the second string. Now I have to search whether the first string is a subsequence of the second string. That means all the characters which are there in the first string must occur in the same order in which they are in the second string. So I start with position equal to 0, flag equal to 0. So anyway, flag need not be 0, but flag should be there. So I start from each character in the outer array, that is in the subsequence array, and in the original array I start from position, go on matching. If C is equal to s2.char at I have a match of a character starting at that position. Then I say the next position which we are going to work with is pos plus 1, because I have to start looking at the second string from that position onwards. I should not look at the earlier, because I have matched it and then it has to continue from that, correct or not? Then I have to say position plus 1. I have to say flag equal to 1 to indicate that I have matched. And then I come out of the inner for loop, I check flag equal to 0. That means I have not had a match at all with any character. That is a problem. I exit with false and then I come out. So, shall we try? Any problems? Okay, let's try. So we'll give two strings. Okay, AXC and AHBGDC. Okay. Okay, we should get a false because the X doesn't exist in the other string. Okay, let's try something else. ABC and something, no? A, H, B, G, D, C. So we get a true, okay. It should get a true because it is existing there, correct? Okay. Now, did everyone understand what we did? Did you follow what we did? We did it in front of you because you need to understand how the code is to be developed. Okay, so this is the code. I don't know whether I need to explain again. See, the line 9 starts the loop on the outer string meaning the subsequent string, and then the only, if you will, the only smart thing in this code is what? Where do you start looking in the second string? You should start always later than where you found the previous one. That's one small piece of logic. Second is, you may find it, you have to understand how to find it. This is a common problem with the for loop. If you find it, there should be some way to say I have found it, that is that flag. There should be some way to say I have not found it, which is flag equal to 0. So if flag is equal to 0, it means I have not found it. I cannot have this string. So I give a false and I come out. There is no point, once you have not found one character also, you have to give a false. Otherwise, if you have finished the for loop, inner for loop and outer for loop successfully, which is what happens down, if you go down, then we say print true. That means there was no exception, there was no reason to come out, and we printed a true. So this is how you should go, simple, systematic, clear. Different people would have done differently, but this is, I think, the most straightforward approach that we can do. The other ways of doing it, searching, replacing, all that, that also can be done. You can do a find and search from that index in that character. That is another way of doing it. Anybody did with index? Using index. You can do that. You can take a character, search from that index onwards. Same logic. Okay? Index plus 1, where you find previous one. The moment you don't find anyone, index gives -1, give a false. Okay? You want to solve it with index? We can do that. Okay. Let's see one or two solutions. This is counting. Answer. Count is not important. Count will merely check for presence. See, I hope, some of you, just now what code I saw, they are counting the character. That is not what is required, right? Count will only tell whether this is there or not, but what about the sequence? It has to occur in the same sequence. Same sequence means if this is after that, the character should occur after that, not merely count. This is very similar. But this looks like an after effect. Before only it did. Who is this? Abhinay, 11:9. Good. I think some of you have used a stack, which is good, because you can throw away, as you go through the string, you can throw away the characters which are not lowercase or uppercase, which are not alphabetic character, and which is either blank or number or whatever, and then put them in a stack, and because you have to reverse it, just pop them from the stack, you are done. So I think let's see some solutions, or okay, let's see a solution here. Somebody's solution, whoever has done earlier. Yeah, they have used a stack. Okay, now there is this thing called, how do you check a string is alphabetic? Character is alphabetic. There is a method on a character class. This requires a little bit of search on the internet. How do you check a character is alphabetic in Java or not? There is a character class on which there is a static method called is alphabetic. That's why it is invoked directly on the class. So that will enable you to check whether the character is alphabetic or not, lowercase or uppercase. If it is not, then you don't need to take into consideration, correct? So I think this code is doing that. Okay, let's walk through the code. Looks good code. Okay, so let's make it a little bigger. Okay, so we will go through it. The scanner, next line, reads the line because it has spaces. You have to use next line and not next. So it's always better to use, whenever there is spaces, use next line, and that is possibility here. Then check whether S is empty. That is a border case. If I give you an empty string, how do you say is it palindromic or not? Well, the answer should be it is palindromic, because you can't prove it is not palindromic, right? So if S is empty, blind return true. This is, well, you have to figure out this case if you are checking out. Then else, so we come to the else part. You create an array of you create a stack of character. This is how you do. You don't say char, you say character, that the wrapper class. We'll soon study wrapper classes, but I think you can make out. It's a character, it's a object version of the character. So stack character, is creating a new stack. Then the entire string S which is given is converted to lowercase. No problem with that, so you just have to check in lowercase. Then string D is equal to empty, fine. For I equal to 0, I less than S dot length, I plus plus, that is go through the entire string. If it is alphabetic or it is a digit, which is good check. Yeah, can we go a little right? This is a good check. If a character is alphabetic or if the character is digit, see the way it is checked, nice way. Character dot is alphabetic, that is a method on character class which says s dot char@. If you want to check how it is a digit, you just say character dot is digit. This methods you just have to use Google. You will figure out. You are not expected to remember everything, and you should not. That's the other creed of a programmer. Don't remember too much. Understand utility more. Don't waste your memory on remembering. It's all available, okay? And slowly you will get to use it. So if character is alphabetic or character is digit, it is our type of character. So we push it into the stack. And I think she's also adding it to D, though that may not be needed. That is to check it is palindromic. Yes, it is needed for sure. Then we are done with the loop, and we have this all the characters sitting there. And now we say string R is equal to some empty string. And while stack is empty, while stack is not empty, that's a nice check. Pick the character, take the character. Pick means it will take the top of the character but not remove it. It will show you who is at the top of the stack but not remove it. So R plus equal to st.pick, st.pop. Now you are done with the character, you have taken it, put it in your string. So R will be the reverse version of the original string, which is good. So if R equals D, D is the actual version, R is the reverse version after removing all the nonsense character and retaining only the digit and the alphabetic character. So if R equals D, wonderful, then system.out.println true, else false. That equals is a string equals, which checks for what R and D are pointing to. R is a string reference, D is a string reference. Whether they are pointing to the same character is checked using equals. And it is true, it is false. It's very nice, very, very good way of writing, right? Okay. So this is the method. Okay. This is the way it is. It's easy. The other way to do it is create that string D and then reverse it yourself In order for reversing, you can go convert that string to string builder and then reverse it as string builder, bring it back to string and then compare whether they are same or not. Or the other way of comparing is using a stack. Stack is also perfect because when you do it, the last character will come out first. So the string which comes when the stack is vomited is a proper string, and if it is equal to the original string, then it is palindromic because it will come out in the reverse automatically. And if that's equal to the original string, you are done. So very nice code, and oh, this is different. Okay, this is different. So let's see how this is done. Oh, somebody has done exactly what. Who's this? Sai Govind. Who is Sai Govind? Good, good. Very elegant. You go to, this is what I was talking about. He is building the string exactly the same way the earlier person was building. That is eliminating non-alphabetic, non-digit characters, adding them into string, making the big string. By the way, you don't have to do so much. K is equal to K plus. If K is a string, just concatenating that character will do. You don't have to do value of all that. The good thing is in Java, strings are all enclosing. You add a character to a string, it becomes a string. You add an integer to a string, you just have to say plus and add whatever to the string, it will become a string. It will be string concatenation. So rather than doing all of that, you could have simply said K is equal to K plus h dot char at I to lowercase. Of course, you have to convert it into lowercase if you don't, if you want to do the comparison in lowercase. So string m is equal to new string builder, reverse to string, very good, and then equals k, we are done. Very good. Okay, let's see one more variation if it is there. We have seen two. One is using stack. This person is not using stack. This person is using string builder, going into that world, reversing the string, coming back. Good enough. Okay, again, okay, it's checking whether it's a letter, okay, and pushing it into the stack. Only the use of not is alphabetic, is letter. But letter and digit also has to be checked. Letter is including digit. You don't have digits in your test case. Okay, this will also work. It's again very similar to stack. Only thing is, I don't know whether letter includes digit. I don't think it does. So if you have digits here, it will have problems because we wanted to clean the digits, no digits. I don't know whether it is taken care somewhere. No. Okay, let's see one last variation and stop. If there is a variation, if not, we'll. This is string buffer reversing in the beginning only. Okay, this is a variation. Converting it to string buffer. As a suggestion, string buffer, this code, don't make string buffer the first choice. Make string builder the choice. Functionality is the same. I told you the other day. If you want fast, use string builder. Buffer is just thread safe. Don't do it. As a general rule, don't use string buffer. Use string builder. Unless there is lot of multi-threading in your program, string builder will outbeat string buffer. Okay? So don't use string buffer, use string builder only. Though it is not thread safe because it's faster. Okay. Then char at I, so temp, it's converted, reversed, and okay, string temp to buffer string, brought back. Now, so buffer is the reverse version. Acha, now comparing s dot char at I and comparing it character. Oh, you are not bothering to eliminate characters at all. Now this also our test case has allowed it to happen. You know what has happened here? Because you have not eliminated the other characters, if variation is there in those characters, it will give error. Okay, because you are comparing without elimination. You should compare after elimination. Okay. Anyway, we'll stop here, but it's good to see variations. Some variations are good, some are not, but as long as you know why you are doing what you are doing, we are fine. Okay. So we will pause here for today. Continue in the next session.